So in 1977, a baseball card sold for $266, and then it came back up for sale again in 1986, and it sold for $437. We're going to assume exponential growth in this, the value. So let's find the exponential growth rate. So this is a little formula that you've got on your formula sheet. That K value is what we're trying to come up with. So what do we know? We know that in a span of, what, 9 years, this card went from 266 to 437. So I can actually put that into this formula. I'll put in what I know. And then the only thing that's unknown is what that rate was. So now I can solve for K, figure out what the rate is, and then figure out the value going on into the future. So let's divide by 266. And when I divide this fraction out, I get this decimal. So I'm gonna leave that as a fraction. I don't want to round here. So I'm left with e to the k times 9. I'm going to rewrite this as a logarithmic equation. All right, it's basically I took the natural log of both sides and it killed off the e, and I'm left with the power. Now we're multiplying by 9, so let's divide by 9. So my k is going to be this value right here. So let's take L, and I'm sorry, let's take a natural log of, delete everything off, natural log 437 divided by 266, and divide that by 9. That's not right. Natural log of 437. I got my numbers right. 437. Put in parentheses this time. Oops. Divided by 266. Then divide that by 9. 0.05515. Well, 56 if you round that spot right there. Now it says to round that rate nearest thousandth. So here's tens, hundreds, thousands, and this guy tells me to leave that number at the same. So 0.055 is my k value for this function. So now let's write, it asked me for the actual function, right? Yes, where t is the number of years since 1977. So the actual function would be p of t. 266 is your start. E to the 0.055, and then time, and the time is from 1977. So there's part B. Part C says estimate the value of the card in 2010. That's 33 years ago. So we want to find P of 33. So we're just going to plug 33 in. $16, 33, 53. Round the nearest penny. That would be our estimate for what it would sell for in 2010. What's the doubling time for the value of that card? Well, if you remember from, we talked about doubling time in number 47, part D. We want to find out that little bit of information. So my rate, or my k value here, 0.055. So the natural log of 2 divided by 0.055. 12.6 should take 12.6 years. And find the amount of time for when the value of the card will be $2,000. When will it be $2,000? So the output should be $2,000. You just don't know the time. So we got to solve for t, so I'm going to divide the 266 out. I'm want to rewrite it as a logarithmic equation, or essentially take the natural log of both sides, and the e would be canceled, and you'd be left with the power. However you want to look at it. We'll divide by 0.055. So let's take the natural log of 2,000 divided by 266. And we'll divide that by 0.055. You get 36.68. I'll just run the nearest tenth. I think it says run the nearest tenth. So 36.7 years for that card to get to $2,000.